data delineation?
Basically, data is copied into the model. We want the data to be
What you said. Yeah, it's a separate
delineation.
input file.
Separation. Yeah, separation.
Now I understand. That's it.
So does anybody need a printout?
I don't.
All good.
I have it. It's very noisy, huh? Very noisy.
Yep.
You feel like wow.
Yeah, yeah, it's a
Very
very
heat. Very heat. Look at the screen.
Hello.
Hi. Okay. Sorry.
Good.
Yes, good.
Okay. Good evening, ladies and gentlemen. Welcome to the last session of the day. We're going to be following the path of focused on pathways to clean, stable, sustainable energy future. So given that context, our goal is to focus on models and simulators. The idea here is to devise the models and simulators. When I say simulators, it is a policy scenario simulators in a way that it is easy to data wrangling teams or the data wrangling engineers, easy to modelers to manage their models, and at the same time, it's easy for policy stakeholders to consume the stories that comes out of the scenario simulations. So that's what we are trying to address. Allow me to introduce myself. My name is Amarnath. I am the director for products and solutions here at CapsArc. The charter of my team is to primarily collect, wrangle, clean, and get the data out to modelers to improve their efficiency. Once the data has been supplied to them, we come around once the model work is complete, take their model, build a web policy simulator tool that can work online and easy to tell the stories or the insights that comes out of the model. So it's all about data, models, cataloging, and simulation software. That's what my team here does. CapsArc identified this as one of the strategic assets way back in 2015 during fall time that we need to consider the data and the tools as one of the investments that is common shared services for all types of research programs that we have. So without further ado, allow me to introduce my fellow distinguished, esteemed panel speakers. Let me start off with Dr. Andres. He's a professor of energy and transport at the UCL Energy Institute. Then with me, I have Dr. Baltazar. He is associate professor of economics, again at the University of Vigo. Then we have Michelle, and Dr. Michelle is fellow in energy and minerals, because minerals is on our roadmap as well, which just began this year, to collect and understand the energy, economic, and minerals nexus and its impact for the policy pathways. We have Dr. Diego as well. He is a young postdoc researcher, completed his research at Imperial College in London. Now he's working at Aramco as the researcher focused on geospatial and energy economics area. Allow me to introduce David as well. Comes with very international exposure, spent time in North America, Europe, now in Middle East, again working for Aramco as a senior economist working on energy economics subjects. With that, let me quickly run through, if I missed any of the accomplishments by our key speakers in here. Again, as you see, Dr. Andres spent enough time in, again, US and UK as well, very closely working with the airlines. He's a trained aerospace engineer, now working on energy economics and systems modeling. Coming back, Dr. Baltazar has been working with CapStark as well in last 10 years or so, helping us on various macroeconomic models and insights. We are looking forward to work with Dr. Michal, coming from Baker's Institute. We want to learn. We are new at CapStark on the minerals, looking forward to learn. Again, Diego is working on spatial. We have a special program in CapStark on the spatial, so looking forward to work on that and learn from him as well. And again, David with a multifaceted background on the energy economics. So the topics that each one of them is going to be covering is in here. I'll be focused on more about models. How do we make modelers' life and policymakers' life easier from a technology perspective? I come from a computer science background, and we want to find ways how we can help the modelers. And when each of them goes through the remarks, you will see the topics. So with that, let me talk about a few minutes on the open data platform that CapStark has. So since last 5 years, we put together this data portal, and it is open. You don't need login, password, anything likewise. All you need to do is search in Google, CapStark data and tools. It'll take you there. So any data that we use within our research, as long as we got it from the open websites, we crawl around 300 websites to pull the data, make them consistent, add it into one format, and share it in the portal. And it is open for the world to use it. Once we have this data, this is the list of models that CapStark has worked in last 10 years, around 39 models precisely to add on. Each of the model comes with its own complexity and its own inputs, outputs. We are trying to figure out how do we catalog it and make it generic such a way it is easy for us to build the simulators on top of it. And on the right side, you see the simulator examples that we have built. And I'll show you a link where you can find it. This is one example where eps.capstark.org, where you can go and see some of the inputs that is being supplied to the model. You can browse them, and you can run 50 and odd scenarios and see the impact onto the policy. What we are trying to envision here in CapStark is to build a simulation lab. So what that means is that any model that we use, we should be able to allow other users to also run the same model. So for that, at this point, around 15 models or so, we have built the simulators, and it's already on a website. You don't have to log in. You can join them. Unless some of them needs confidential data in it, then you need to contact with us, and we can set you up to see if there is a way to access. Here's the list of the models on which we already have the simulators on the left, and the list of the models that we are going to be working. If any of these is of your interest, we are happy to work and collaborate, because the innovation cycle will propel when we collaborate and coordinate. Here's some of the examples of the simulators that we have worked on, the input, output. So when you look at these models, whether it is a CGE model, partial, full equilibrium models, balanced models, input-output models, econometric models, agent-based models, you name it, there are models that there exist. And we are trying to make sense out of which models will be applicable, for what scenarios, which models should be using, and that models, what data we can supply. And once we have the data model lined up, what simulators we can help them to tell the stories using that. We are approaching this more from a product development, product management, and a software services type approach so that we have good products that can evolve over a period of next decade or so. I'll quickly skip. This is kind of an evolution of what kind of models that we worked here in CapsArc. And let me focus on this slide for a minute, where some of the key challenges that we had to run through while we were developing. Like this year, we're going to be developing around 5 or 6 simulators. Challenges are data availability. We talked about it enough. Each one of you is aware data availability is always a challenge. And then when you find the data, it is not very clear on the use terms. Meaning, what do you mean by use terms? The publisher hasn't very clearly given the license explanation of when we can use what we can't use. So now there are evolving standards like Creative Commons, ODBL. You see them on the right as the screenshots. So I would strongly urge the data publishers to refer the standards, thereby the modelers and the data wranglers know how to use the data. Again, there are challenges around data versioning and recipe versioning. What do I mean by recipe? When you get the administrative data from Statistical Institute, wherever you get from, you always do some transformation so that you can fit into your model, or you can apply and supply into your model. These recipes are so precious because your model outputs depends many times on how you consumed your model. So what we are trying to practice at this point is, if these recipes can be stored in Python, in spreadsheet, whatever the format, you got the input data, whatever the recipes you applied, we are trying to catalog these recipes and also make them available for the users. So you have data available, recipes available, and now you are able to use those recipes into the model as long as the models are open source. So that's another key challenge, because we find models, we find the data, but we don't know what magic has been done before it's applied into the model. And delineation. Many times the modelers inscribe the data within the model, and it becomes very difficult for a database management and versioning. Another challenge is the crosswalk across the models. So how do we take elasticities from one model and use it in another model? And where are the assumptions, and in what context can we use, cannot use? These documentations are less. So we are trying to get to a point where we could record, document, and attach them along with the simulators, like how a commercial software would have its help files and reasonings and methodology, all of them in the simulator attached. So, and also based on the last 15 simulators that we have created, we have arrived at a user interface which we think is generic enough, and I'm looking forward for the feedback to see if there are other items to be added so that we could use a one user interface template to tell the story of the model insights. So there are some solutions, either be creating the bots using Python, Beautiful Soup, and other technologies. Technologies have evolved quite a bit in last 5 to 10 years. Many of them are open source. You go into GitHub repository, which is the world's largest repository of all the software code, you pretty much find 60% of the answers that you want to do. Either it is with data wrangling, or it is to do with manipulation, or creating the user interfaces for your model outputs. We have a solution. This is one of the design patterns where we came up with, saying there should be a policy selector where it selects the levels of what scenarios you can run, and you are able to save the policy settings, and we are able to browse the inputs in the simulator, and you're able to see the assumptions the model uses in the simulator, and the methodology papers attached to the simulator software. And then you are able to see the output, you are able to slice and dice the output, and have the APIs into the model, so one model can connect with the another model without going into user interface, and have the reports associated with. So this is the pattern that we are going to be using as we go forward. Looking forward to work with those who are interested to gain feedback on it. Again, we take the models from the researchers, whether they worked on the GAMS, UViews, MATLABs, whatever. We make them as almost like a commercial software, which is available for the energy stakeholders to use. And we use the modern technologies, be it Angular, React, and others, to basically translate the model into very easy to use interface. So with that, I am wrapping up my closing remarks. Again, it is easy to find many of our tools and data sets, so just Google CAPSARC data and tools. It will get you there. We will find ways to collaborate. With that, we will go on to it's opening remarks there, but again, with that, Dr. Andres, take it away.
Thanks, Amar. Good afternoon, everybody. I was already in a session at 11 a.m., which looked at data in a similar context, and I already described the activities of my lab at UCL. So in case you were there and you wanted to check your email, now would be a good time to do so. So what we do in my lab is we simulate the global air transportation system. And in particular, if we change a little bit here or there, if we add a new runway at a capacity-constrained airport, if we introduce disruptive technology, hydrogen aircraft, electric aircraft, and the like, or if we introduce climate change policies, then we are interested in understanding how the system responds. So you change something here on one end, and you see impacts propagating all through the other end of the planet. And of course, this requires modeling. And the models that we produce, they're all open source. So we try to make them available to the community and for the society at large to produce a common good, if you want. And an important part in order to generate credibility, we need to validate these models. And what we do is we publish papers also on the validation alone in international leading peer-reviewed journals. And in addition to that, we've got a very thick manual in which the key equations are all reported and all the coefficients of the underlying regression analyses and so forth. Now, Amar had a couple of key requirements or key challenges. So one was data availability on use terms. In terms of that, we cannot make available the input data because of data confidentiality. This is very expensive commercial data, so we have to take that out. But the workhorse of our models, this includes the coefficients that are based on these commercial data, and the model is fully operational. You don't actually need these data, and you could actually re-engineer these data to some extent, obviously not at the level of confidence that you would like to have. The use terms are also clearly specified. So this is a Creative Commons license. I believe we use the MIT license, which allows you to use the model for personal and commercial purposes and to modify it, and you're not forced to make it available for the community again. There's a version control, and Amar already referred to it as a critical challenge in order to be able to reproduce the model once. And also importantly, all the input data are in, now I don't know how many, whether it's only one or multiple input files. There are no files embedded, there are no input numbers embedded in the code. And the person who has programmed and coded the model is a very savvy and a clear thinker, which helps, of course, and a very experienced programmer. User interface, in this particular case, don't expect anything glossy. It's an academic model, and the expectation would be that you know how to operate Unix and the like, which is straightforward by itself. So most of these key challenges are actually satisfied. It is certainly easy to use, and we used it in collaboration with industry and governments to advise them on certain policies, and it's also widely used in the community. The IAA uses it for their aviation assessments. The French Ministry of Transport uses it. The UK Department for Transport wants to use it. Various, big, what's the right word? Corporations use it in their respective research departments and so forth. One concern, of course, that we have, and we've got already experienced, is the misuse of the model. So you can easily use it and you can post-process the outputs and then claim that this is the result of that particular model. And this makes us a bit uncomfortable, but we haven't found a strategy yet of how to deal with this aspect. But otherwise, I think we have experienced very positive feedback, and I think I'll leave it there.
Great. Good insights. Maybe one follow-up onto, are there ways to delineate within the model open versus private data? And at some point, we need to find proxies to replace commercial data. If you cannot, we cannot. But we want to attempt. That's where we are trying to approach to see. Because if you have to improve the pace of research, it is very important. The elements of what goes into research has to be reproducible. And in many cases, it's not. We're understandable. Say one anecdote example, like Elon Musk's flight is always tracked by a student, and he posts where he is. If that can be done by somebody using whatever the technology that exists, are there similar ways that we can, you think the future computer scientists and the digitally very able new generation coming in will have ways to get the proxies for this expensive data that we cannot allow them to reproduce or share?
So if we look at, for example, the demand model, which is a function of income and population and income distribution, Gini coefficients, and the airfare. And of course, you need the observations in order to estimate the model. Yes. The observations and the airfare, so the passenger kilometers and the airfare, these would be the commercially sensitive data. You can have easily access to the other ones. So in terms of income, household income data, population data, and income distribution data for urban areas. So making assumptions or getting approximations for the travel demand would allow you to infer about the airfare, for example. So it is possible within limits, but there's still some uncertainty associated with it.
And model may be able to manage with that kind of proxy data at some point.
Yes.
Great, thank you. Well, with that, Dr. Baltazar, your opening remarks, please.
Thank you very much, Amar.
Because it was too far away.
Yeah.
So it was really hard to hear.
Thank you, Amar, for the invitation to participate in this panel. I just want to make some general considerations about the use of models for policy analysis, and those considerations are just based on my experience using macroeconomic models for policy analysis with some elements of energy policy too. In most disciplines, we always start with a question. It might be a policy question or a question not necessarily related to policy. And we tend to use formal models. Why do we use formal models? We want to use it because it's a way to introduce scientific discipline into the analysis. And this imposes us a certain coherence in the description of the agents, markets, and mechanisms that operate in the model. Models are important, but not only because they give us quantitative responses to the implementation of policies, but also because allow us to understand what are the transmission channels of the policies. In general, we want to understand the transmission mechanism through which the model operates. So the idea is that we should avoid black boxes. We know that models become bigger and bigger, and every time is more a challenge to avoid this temptation of use a black box and only focus on the final results of the model. As George Box used to say, all models are wrong, but some models are useful, and a model is no more than a simplification of the reality. But for that simplification to be useful, it needs to have the key ingredients, the key elements to answer the question we want to analyze. And what I consider important is that in order to determine what are those key elements, theory and data, they play both an important role. These necessary ingredients sometimes lead us to a methodological election between different types of models. For instance, if you are interested in a question that requires a model with a higher disaggregation of the economy, you would probably choose a CGE model because it's providing, has advantage providing more granularity in the results. But if the question requires a dynamic approach, for instance, with agents making intertemporal decisions under uncertainty, then a dynamic stochastic framework will be more suitable for it. Another important element to build a useful model for policy analysis is the calibration or estimation of the model parameters. And following the discussion this morning, the main issue here is to have higher quality data and enough large time span to have parameters estimated with a high degree of precision that would affect the precision of the results too. And another element which is also key and is frequently missing, I would say a little bit less in academia and a little bit more in policy practitioners, is the validation of the model. But the validation of the model along the relevant dimensions of the economy. If we follow the positivism of Friedman, the validation is less about discussing the realism of the assumptions and more about the ability of the model to explain the empirical regularities related to the object of our analysis. For instance, if I want to analyze the effects of stochastic shocks in an economy, something that we are currently doing for the Saudi economy, I want my model, to validate my model, I want it to be able to reproduce the business cycle regularities of the Saudi economy. Otherwise, I cannot take my model seriously for the policy analysis. So for me, the validation is an inexcusable step to legitimate to use the model for policy analysis. So as a summary, I would say that we have specific models to answer specific questions. Of course, there are models that can answer more than a question, maybe fiscal and monetary policy together in a model, but no model can answer all the questions. And the ideal model, it doesn't exist. There are different types of models which maybe emphasize different characteristics of the economy, or they are able to address different issues, but at the end of the day, there is no model that can do everything. So I will leave it at here.
Great remarks. So you pretty much walked through scenario, calibration, validation. My only question would be, can validation be beyond modeler's exercise? Of course, we talked about the peer review, journal publication. We will definitely go through rigors. But is there a way to open that up validation process to much larger community beyond no? So is there a value? Is there a reason to do it? Any comments around it?
No. Of course, there is a reason to do it because it's a central aspect to take the model seriously for the policy analysis. So a serious researcher should do it himself, but well, the referee process of the journals is like the test that the papers have to pass. And ideally, if you open up a model as we used to do here in CAPSAR, that we allow other researchers to validate the model, to criticize, and maybe to find ways in which we can improve the model along different dimensions that they were initially planned.
Great, that's a great segue. Yes, we talked about in the morning, we want data to be social. You're able to come and critique, yes, I can use this, I can't use this for scenarios. Similarly, hopefully at some point, even the models has comments right there on digitally where people can comment on it. For that, we need to have digitally enabled models that allows that kind of features to be residing along with the model. So with that, next, let's, Dr. Michelle, let's bring in data, critical minerals. It is new for me, at least. Looking forward to hear from you the opening remarks. Please take it away.
Okay, the first challenge is working the microphone. So before I get to that particular thing, Amar, I want to step back a little bit because I'm not a modeler, because I don't have the data that I would really love to have to model the things that I think need to be modeled. So I'm probably in the worst of everybody on the panel in terms of that. I also think a little bit of context would be useful to come forward to the problem where we are today around the world, all the things that we want to try to do and the information that we think that we need to have in order to do it. I was reminiscing with some friends yesterday, so I'm going to date myself. When you have a more than 45-year career, you have all kinds of adventures, and when I was a graduate student at the Colorado School of Mines, if you wanted to do something rigorous, you punched your key cards and took them down to the mainframe and hoped that all of those folks down there actually got your statistical model together the way that you wanted to get it. I mean, that, from there to where we are now is quite a difference. In those days, if we wanted to know something about petroleum systems, we had the American Petroleum Institute's hard copy books, Adam, I'm trying to remember whether they were quarterly or annual, but that was the data that we had available to us on oil production, oil supply, natural gas, and so on. I don't think the International Energy Agency's monthly oil report existed in prior to what, 1985, right? So Bureau of Mines on the mineral side, everything was hard copy. The Bureau of Mines would do these beautiful annual reports, the state of the minerals industries in the United States, what they knew about what was going on abroad. That was the world that we lived in. Mainframe computing and data on paper and very scarce data. I mean, our country, was data rich, such as it was. The rest of the world, data poor. Flash forward to today, where everything is online. We have the power of computing on our smartphones. We can run simulations, we can look at visualizations, and all of that. And we expect the information at our fingertips. And the problem is, it still has to be curated. It has to be collected, it has to be measured, somebody's got to pay for that, it's got to be verified, you have to understand it, and at a time like this when everybody wants to know who's producing nickel, wherever, you're going to pay for it. It's mostly going to be proprietary, and because there's money to be made in the data provision information businesses. You can, subscribe to Dan Yergin's organization and be able to see what's going on in different countries with different mining projects, different minerals output, processing, and so on. But unless you have the budget and are able to pay for that, you're not going to get that information any other way. The dilemma is the institutional catch-up, so that's one of the gaps. We've come so far on the energy side. The Energy Information Administration, our EIA, has just done an enormous service of putting information out in the public domain that's trustworthy, and it's still not enough for all the things that we'd really like to know, and everybody realizes that. IEA has done the same thing. We went through a very tough process of building JODI, the Joint Oil Data Initiative, to try to resolve really hard issues in oil reporting. We're finally at a place where we sort of think we understand what countries are telling us, what national oil companies are telling us about oil production. The periodic table is 118 elements, and we need to know this about every single one of them. And I know people would like to be selective and say, well, only these elements are important, only those metals are important. But if you think about one part of the complex, which is electronics, semiconductors, which control every energy technology and system that we're talking about implementing going forward, that is all 118 elements of the periodic table, plus reagents, solvents, a lot of them that come from the oil and gas value chains, noble gases, and lots of other things that are absolutely critical to material supply chains, cathode-ready materials, precursors for battery manufacturing, and for the electronics that are going to make all of these systems work, much less the infrastructure. So the learning curve on this question, what do we know about the non-fuel mineral side of the equation? How are we going to deal with this? Is huge. And I have no idea how it's going to get funded and who's going to do what. I don't even know in our own, in the United States how we're going to get this done. What we've done at Rice, just to help the public understand, I mentioned this yesterday on our panel on food, water, and minerals. We took the U.S. Geological Survey data on non-fuel minerals production by country, by year, everything that we could get, which exists essentially in paper form, PDF. And we scraped it so that we could build a longitudinal logical data set that we could work with so that we could begin to visualize the data and actually understand what's going on, which countries are producing what, who's got the commanding market shares, where some of the issues are, and all of that. Someone in Washington is going to have to do this on an official basis with our government data in order to solve and start to close the public information gaps. And even our data set doesn't really help to educate people on the complexity of the problems. So who's in control of the midstream, beneficiation, processing, smelting, refining, and so on? How is stuff getting shipped around? It's very hard to track that in the UN trade data. What about quality? I made the comment yesterday, not all of the tonnages are the same. We have variations in quality of nickel, manganese, graphite, lithium, and so on that result because they occur differently in the earth. They have different requirements in terms of processing. This has implications in terms of who is going to do what, at what cost, and in what time frame. At the other end is the customer trying to figure out how to develop coherent supply chain strategies, and governments that are trying to figure out, on the whole, at a national level, what a coherent supply chain strategy looks like and what resilience means in all of this. So we're in the beginning stages, the very early beginning stages, and that ultimately is going to affect timing, ability to satisfy targets or ambitions. One, I guess, last comment to kind of wrap this together in terms of what it is that we have to think about doing. I've done a lot of energy sector development assistance in a lot of different countries, mostly on U.S. government projects, USAID, State Department, and so on. One of the best things that I've seen around the world in donor assistance is help to countries to prepare their data. Because if you're a nation that wants to lure investment to your country, if you want to have competitive bidding to try to get energy projects off the ground, whether it's oil and gas exploration and development, mining, or other things, even infrastructure projects, you have to have a viable data room. The best thing that can be done for a lot of countries that we're going to rely on for raw materials sourcing is to help them figure out how to build those data rooms. So this is an appeal to all of us in the room, to the kingdom, to CAPSARC, as you engage with your colleagues abroad, to bear that in mind. And this is true across Africa. It's still true in Central Asia. So in your own neck of the woods here, there are still huge, enormous problems with information and information transparency in order to know what we can do and where we can do it. So I think that, I think that's a very tall order. I don't know how we're going to accomplish it, except, that we have to just start today and begin to think about how we're going to build the information, the data inventory that we need to be able to execute.
So that's a great summary of where we were to where we are. The work that was done with Jody data, having their catalog, which is, if I remember right, IRIS data dictionary, where every term that's used in Jody data has a definition, and conversion factors, quality of fuels, how do you, specific gravities, and how do you count the volumes. So such type of work in the minerals there exist, or it has to be built? That is one question. And are there models around minerals, or is it too early to even talk about models that forecast the minerals demand and supply and things likewise?
So there is high-level gross data, and I mentioned this yesterday. So in addition to the USGS, which is what everybody goes to, even for their own countries, which is pretty funny. If you were Bolivia, we wanted to understand what your lithium reserves were, the best place to go to look is going to be the USGS, because that's probably the most reasonable estimate. I mean, so we do have a start. We have a start with USGS. We have a start with what the World Mining Congress has tried to put together, but it's not detailed enough. It's not. It doesn't capture other parts of the supply chain. If you were to go to the EIA website, or even Jody as it is now, that's what we need on the minerals side. Nobody is doing this yet. So that's the simple answer, I guess, to the first part of the question. And then in terms of, what was the second part?
So are there any models that you have?
Are there any models? Oh, well, you can pay Benchmark, you can pay Bloomberg, you can spend money and get their forecast of whatever they think, how much is going to be required in the battery metals, for instance, to satisfy demand. I'll tell you that none of those are sensitive to any of the conditions that I pointed to yesterday. So none of them account for demand-side factors, shifts, substitution alternatives, changes in technology, competing uses, and the effect of competing uses. It's very narrow, very siloed, very insular. All they're doing is counting battery factories and trying to estimate what that means in terms of tons, which I think is a complete waste of money. So it's not that I don't like these folks. There are good people there, but we're, again, in the very beginnings of all of this, and I wouldn't really waste a lot of money on it.
Thank you very much. So with that, let's now have the introductory remarks from Dr. Diego. From the 4 decades of experience, insights that we learned, now Dr. Diego is fresh out of the university, just completed the postdoc, has his hands-on to Python and geospatial tools, and so please go ahead and give your perspective on data models and simulators.
Thank you, Amar. Also, thank you to the panelists, and thank you to the organizers. Yes, I would like to introduce a provocative question we say in the academia. How do we arrive to these levels of emissions right now? So, and I want to blame ourselves, energy modelers, because we're supposed to be the ones that inform policymakers and also inform firms to take decisions. So based on that, what we were doing back in our team is try to see, okay, how can we change that? How can we introduce more realism in models, so to take a little bit more realistic decisions? So then we found, just to summarize, we can classify models maybe in 4 big groups. We have the optimal growth models, general equilibrium models, partial equilibrium models, and something that is coming now and is getting popular, the integrated assessment models. And within those integrated assessment models and also partial equilibrium models, we can have energy system models. So for those models in overall, there are two main schools of economic thought that rule the assumptions, how we treat data inputs, how can we do the calculations, and how we finally do the analysis of the results. So this we call it the mainstream. The mainstream is what is called also the neoclassical approach, and also we call this post-Keynesian economic theory. So basically, the mainstream consider firms and consumers, we call it agents as well, as a representative single entity that take prices as given, make rational choices with perfect knowledge of the market, and the rational expectations, optimal expectations as well, to maximize utility or welfare. Something that we call it hyper-rational representative agents. So that's on one hand. On the other hand, we have this post-Keynesian school of thought that recognizes the imperfections of the system based on inequalities, imbalances, and efficiencies. Human beings, we introduce those imperfections in the system. So while the mainstream systematically disregard the connections between human beings, natures, and institutions, and only leave the connections between commodities and consumers, or firms and consumers through commodities prices, so we finally disregard or neglect the limit of the nature in this analysis. So while the mainstream considers, for example, heterogeneity of agents as a source of bias in the analysis, post-Keynesians, they consider it as a source of realism in the analysis. So there is these two main schools of thought that we need to deal with in order to treat the inputs and do the calculations and finally have results and analysis to inform firms and also policymakers. So, but both schools of thought leave some room for a third path or a third way of treating data. So when we see this, we can still identify some challenges in modeling. So one of those is capture the special dimension or within models, as what you were saying. So for example, just in a single city, the income can vary across in different places. And sometimes we assume the same average income for the whole nation. So the same thing can happen for energy demand. Just the energy demand can vary from one city to another. And what we assume in models in general is the average energy demand per capita to introduce in the models. So another challenge is the introduction of the human dimension that we can, for example, parameterize or define how consumers make decisions. So there are some specific rules. For example, if right now I ask you, how many of you have this specific brand of cell phones and this other specific brand of cell phones? Definitely we are going to have a range of different brands of cell phones. But then I ask you, what were your specific investment goals to pick that technology? We are going to have different results. So maybe some is because fits their budget, fits their expectations, or maybe just they like it. So the same thing applies for energy technology. For example, if we are in a household and we need to meet our energy demands for heating or cooling, so sometimes we just want to keep the same comfort as we have before. Or maybe it's a person or it's a family that they want to have a more environmental friendly technology. So there are different investment goals that we need to consider in the analysis as well. So for that case, we need to run long or national-wide surveys in order to have that specific information. So then we have other challenges, for example, addressing transparency and reproducibility, and also capturing the complexities of the whole sector. But right now, just to finish, I would like to, how can we introduce this realism, capturing the spatial and temporal dimension, and the human dimension in the models. And we found that basically there are 5 key characteristics to define these agents in models. So first one is agent heterogeneity. So we need definitely to define agent heterogeneity within models, and we found that could be just with 3 characteristics: the level of income, the energy consumption per capita, and the propensity to consume energy. And then we need to define agent diversity, because we are all different. So we can do with a range of parameters here. For example, budget to allocate for energy technologies, the level of demand, technology stock, what is the current technology that we are using right now, cultural and socioeconomic characteristics. There is one specific one, which is called the Human Development Index. That is a very interesting metric, because we have the level of education, the access to health, and the quality of jobs in a single metric that we can define diversity for specific agents. And then how these agents evolve in space and time. Also the decision-making processes, as I just said, these investment objectives, how we pick a technology and how to finally invest, because that at the end is gonna let us know which fuels is using that technology, that finally at the end we have the mix of fuels and technologies. And finally, we definitely need to introduce this, what we call exogenous constraints, like policy constraints and also market constraints within the model. So I leave it there. That is something that we are researching. How can we introduce this realism in the models in order to provide more realistic insights to policymakers and firms?
Great summary. One follow-up question is, the technology evolution, and you talked about index. If you can elaborate a little more, that will be helpful so I can understand. And also, since you coming in from the academia to Aramco as an industry, so how has the technology life cycle, as you as a researcher, what tools and technologies you use to approach in solving a problem versus what's being used in the industry, and how do you bridge the gap? Any comments around that will be helpful.
Oh, thank you very much, Amar. It's a very interesting question, because when we start these discussions, or when we start to look what is the best approach to solve to address a specific question, yeah, tools are key. So some of the models out there are black boxes. You cannot access to them. You don't know what are the main assumptions. You don't know what are the main inputs, how they treated that data, how they developed the code. You don't know that. You just use them. Even if you hire these consultancies, companies, you don't know exactly. They never release the data inputs in either the scripts to see what's going on behind. So definitely we need to develop new tools. Now we have open source tools like R and Python. In my case, I use R, Python, QGIS, which all of them are open source softwares. And right now, actually last year, we just released the model that we developed at Imperial, which is called Muse. You can Google it, Muse, GitHub, and you can download it and start playing with it. The same issue as my colleague said, obviously we cannot release the original data that we use because we have different policies to follow there. So, but you can use your own data to start working with it. And you can see the code behind, you can see how we do calculations, what is the algorithm behind, what is the main assumptions, and there is a range of documentation right now to start using the model. So, yeah, so far, I think the key is to develop our own tools based on this chance to leave the people, leave the public to see if we are doing something useful, or something that can be used for their purposes.
Right. So we'll come back to the index question later in the follow-up question. With that, let's now, David, with your international exposure on all sides of the continent, just go ahead, take it away with your opening remarks.
Thank you, Amar, for the kind introduction, and thank you for the invitation to sit on this panel. So I'll split my remarks really into two. One, I'll put on my far less than Michelle's experience as primarily as a modeler and an analyst industry, to just sort of sketch out how I think the developments in technology and shareable models as well as simulation tools, I think have helped or can help fill in capacity gaps to help evidence-based policy making. And then the second bit, I will talk, again, having been an ex-regulator, looking at how, again, technology and visualization tools and things like that, developments, can help policymakers inform and give access to a much wider audience on regulation policy decisions, some of the trade-offs and that kind of thing. But I'll do that by effectively less technical and perhaps using a few illustrations. So I arrived in Saudi Arabia about 9 years ago. It was a couple months after the King Abdullah City for Atomic and Renewable Energy had issued a white paper where they were effectively proposing to develop 54 gigawatts of renewable by 2032. Now, that may not necessarily mean much, given obviously we've, I think, just hit 1,000 gigawatts or terawatt hour in terawatts in installation, but at the time, the total cumulative capacity globally was, I think, was something 120. So it was perhaps one of the biggest announcements, you know, a fairly huge moment in terms of the solar PV. And so, of course, there were lots of questions among stakeholders in Kingdom. How much is this going to cost? How does the cost of PV compare to, you know, why should we compare to building more CCGTs, for instance, cost competitiveness questions. We're talking about jobs. Where are those jobs going to come? How many of those jobs are going to go to Saudis? So there's a lot of, clearly, as you can see, policy questions around a fairly key announcement. And one of the interesting things now, on the data side, obviously with technology, around the globe, you had a lot of data beginning to be accessible, but not less shareable models. But at the time, the likes of the US National Renewable Energy Laboratory, for instance, were actually ahead in this. So you could go to the NREL website and you could get the JEDI models, which were economic impact models, where you could, for various renewable technologies, you could get access to, you know, I could send some of the younger analysts in terms of, you know, level cost models, where you can, you know, the idea is obviously training in with new technologies where there's no context, they can train around how to make models, simple policy models, but also for those of us who are a bit more seasoned, it's understanding, you know, what cost assumptions are other people using, performance of new technologies and that kind of aspect. Now, fast forward, you know, 5, 6, 10 years later, and this is impressive development. The capacity has clearly now been built in Kingdom, and car care is an exemplary center of excellence, an example of that, where, you know, we have all these shareable models. Car care itself has been able to develop a long suite of data in terms of solar and wind yield data, very, very detailed information, GIS, that, you know, that you can share. The General Authority in Statistics now has published, I think for the first time, an input-output table. So the capacity took time, but now it's there. There's a lot more interesting work being done by analysts and researchers across the Kingdom. And I think this is one way where I presume the experience, if you mirrored it across the globe, someone sitting in Chile, for instance, trying to understand how can I model the cost of techno-economic cost of renewables, perhaps would have reached to those kinds of shareable models. And I believe and I think it's pertinent now with energy transition because you're seeing the same challenges. You know, we're talking about hydrogen, we're talking about CCS. There isn't necessarily, and there's a lot of fantastic reports by academics, but also organizations such as IRENA and IEA, but they're often slightly black box because, you know, the input assumptions aren't necessarily as clear. What cost did you use for your, you know, for your cost assumption or technical specifications did you use? And I think when you have shareable models, they, in a sense, it keeps the analyst honest because you have to present it and you have to show it, and I think it gives sort of a shared understanding of a lot of these things. So I think that's one way where I think if some of the big forecasters and some of the big modeling organizations step up, share a lot of those, then you build sort of like capacity in terms of understanding where it's not really a question of the costs of, the cost decline rates for green hydrogen just too aggressive, and that's why we're getting this massive, build-up deployment in these particular technologies. So I think it has helped, and I think there's still a room for a lot more scope for the likes of the work that CAPSAC and others are doing to be able to build that shared understanding and but to the next point, I think for policymakers, now putting on my policymakers, having worked with the Ofgem, the UK regulator, for a while, and I remember, again, another sort of similar experience. I think when I was at Ofgem, at the time, one of the biggest issues was the cost of energy, of electricity bills. And the reason for that was we had a big ramp up in the UK in renewable energy. And so, of course, massive transmission and reinforcements, investments, and those aspects. And you had renewable obligation costs weighing on, and so the regulator has to step up and has to issue and inform the wider public in terms of how much of your bill goes to which constituent, and that has to be shared with trying to manage expectations and manage in terms of people, the media and other aspects. And I was going back, I think, to the Ofgem website, I think this past week, and I looked, obviously, the more the world changes, the more it doesn't, so now the drivers are different. Russia, the war in Ukraine and the impact, particularly on gas price, mean bills have risen, exponentially, well, not exponentially, but considerably. And so the same issues, the public want some fairly easy understanding in terms of what's driving the cost of bills, and so Ofgem steps up. But this time you see a bit more than we were doing. Back then there's a bit of visualization tools which tells you can estimate in terms of what the impact, particularly of gas price would be, and it's not necessarily specific to Ofgem. You look at the ways the IEA present some of the work. There's a lot more interesting work, technologies being used to, particularly for wider non-technical audience, present fairly very simple concepts, I think, in a way that helps the public understand some of the trade-offs. And I think this is particularly going to be useful in the context of we've been talking a lot about pathways, but pathways, multiple pathways, trade-offs that you choose, and with very, very different implications. And I think, particularly in discussions about the energy transition, this is where visualization tools by policymakers would be very, very useful, because if I go to, say, for instance, the National Grid Future Energy Scenarios, which publishes similar work for the UK, being able to see in terms of what if we choose perhaps not go fully electrification, or what if we minimize the role of hydrogen? What are the implications at a very, very simple, non-technical level? So I think technology and smart use of technology is enabling that. But I would, and I know our focus here is on models, shareable models, simulation tools, but I'd go beyond that, I think, to the wider technology set. So, for instance, one of the things that I've enjoyed last year were the Oxford Energy Institute, for instance, with a podcast series where they're talking about, they had a series, and I think on Russian gas, a couple of series. So those are, it's an example again where you're using technology, not necessarily for visualization or other aspects, but to try and either share wider concepts, wider research, and I think in ways that's definitely, I think, kind of interesting and ones we should be promoting. So I'll stop there.
Great. One follow-up question, though, is that there are two extremes, right, where everything is open. Data is open, and model is open, and simulator is open. To another extreme, none of it is. I think, to be realistic, every organization, if I ask Aramco to keep their open models open, they're not going to. It's not at their vested interest to share all the trade recipes and secrets out to the wall. Similarly would be it IAE, I heard like IAE is a black box 3 times in this conference already. So But there need to be somewhere a happy medium where at least you can get the calibration data out. Like, for example, the cost data is out. You may not know all the components of it, but there is a layer, there's a abstraction layer of calibration data that is available for you to use and, into the context you need. So what are your thoughts around, well, data is open, at least I think that is the lowest common denominator. At least make sure that is open where it is possible. And wherever it is already private data coming in from the paid subscribers, we need to quickly find the alternates, proxies, and share among the modelers. So that way, the academia and others has some starting point to go with. And then your thoughts on, is there what elements of the model, if we make it available, if not the entire model, will be very useful for economists and modelers, you think?
So I'll have to paraphrase, I think, as my fellow panelists also mentioned. I think a large number of models are all obviously typically designed to answer specific problems. So in a lot of cases, they're not going to be shareable, and there will also be fairly large in-house models which answer more than one. You're in the power sector, for instance, which is my area of expertise. If you have a large, Plexus model, it's not necessarily feasible that it's going to be shareable. Yes. But having said that, I think to your point about the commercial sector, you're right. I think there's always going to be sort of like barriers in terms of being sharing that. But what I find interesting is even for the content providers who sell that data, there is now a move to be a bit more openness. So for instance, yes, subscription to Bloomberg New Energy Finance, as an example, is incredibly expensive, but at the same time, I think if you do subscribe, you can get almost all their suite of models and those kinds of assumptions. So it's not just the data and then the reports anymore. So I think even in the commercial sphere, I see good tentative moves around that kind of openness that helps build the capacity. Now, I'd love that obviously to be shared also on the public side, but I think that's really around, that will take time. It will take potentially national initiatives where, say, for instance, in the Kingdom, if we feel, there have been a series of initiatives taking the Kingdom as an example. A couple of years ago, there was a big initiative on open data. So a lot of agencies were publishing the data. And if we do feel, I think there's a clear need to sustain the efforts like what CAPSAC is doing and to a certain extent GSTAT is doing, then I think there's really every merit to fund that so that you have that wider pool of models. I don't know whether that.
Great. Great remarks, each one of you. Let me quickly go by one question each, and then we'll open it up to the floor for the questions. Starting off with Dr. Andreas, how to make transport models available to energy stakeholders? You said your model is there, that's great. And a follow-up would be, how complex are these models? And what are the resource requirements if I need to take your model and make it operationalize it?
So the first question, I think we discussed to some extent already in terms of how we make it available. In case you're interested, you can download it or download them in the meantime from our website, atslab.org. And there are essentially two models. One is a integrated aviation systems model that has one global representative airline. And that's a simplification. And the only one or two other models that have been built in that space have very similar assumptions. It makes the model run very fast. So I think it takes half an hour to an hour to run, the annual time steps from today until 2050. The simplification has drawbacks, of course, because it only looks at the averages it looks at whether the adoption of specific technologies is economic on average. So it doesn't take into account market heterogeneity, which is critical if you look at the heterogeneity, particularly in the airline market. There are low-cost carriers, there are network carriers, They've got different aircraft, they've got different networks, and as a result of that, individual technologies may be cost-effective in specific markets. So let's assume, all-electric aircraft operating along the essentially bus routes in northern Norway. They might be cost-effective, but this one global representative airline model may tell you it's not cost-effective on average and will not introduce the technology. Now, this market heterogeneity you get in return with a much more complicated model, because then we need to model each individual airline and maximize its profits within its network, and various decision variables that determine under what conditions the profit is optimum. And we do the same for airports, because they can set the aeronautical revenues, and the charges are then passed on to the airlines, and there's an iteration between these two. So that's getting quite complicated. And in this case, you also need an optimizer, which you need to link to the models. And the resource requirement in this case is significantly larger. So when users think about using any of these models, they of course ask the question, what does it cost me? Do I need to hire someone in order to operate the model? In the first case, it's probably half a person to a person. In the latter case, it's certainly more than one person. And some government agencies, they make the effort and generate or find the resources for the first one. But the second one, we have no experience yet, because we are only about to make it available.
Thank you for that. Next question, maybe Dr. Baltazar, for you. What is the expectation on the information, the policy expectation itself, and credibility of policy analysis? You kind of covered it, but how do we ensure the credibility of the models continue to stay high?
Well, before answering that question, and somehow related to that, I want to have a comment.
You may want to keep the microphone a little closer.
Sorry. I want just to make a comment on what Diego said about this dichotomic vision of the macroeconomy between pure neoclassical or pure Keynesian view, which to my view as a macroeconomist, I don't think is true anymore. Now, modern models consider nominal and real rigidities. They consider a variety of heterogeneous agents, for instance, because there is difference in gender, because there is difference in productivity, in many other things. So I think that in macroeconomics, we don't have anymore this ambition to have an holistic view like in the old ISLM model or the neoclassical synthesis. I think that we are something, there has been some advance on that. And regarding to that, in the advancements in the last decades about the design and evaluation of policies, now the models explicitly consider different decision-making processes, as I said, for different type of agents, rigidities, etc. Constraints, and something what is particularly important is the uncertainty sources that we have. And one that I consider particularly important, which is the policy uncertainty. So models now, they specify what is the available information and how the agents use that information to form expectations, not only about the behavior of the future, the variables of the future, but also about the evolution of economic policies. Among those characteristics, there are two that I consider particularly important. I already referred to those two, that are having models that are dynamic and stochastic. Why do we want to have models that can be dynamic for policy analysis? Because for many issues, that is crucial to distinguish between the short run and the long run effects of policies. For instance, yesterday there was a paper by some colleagues here in Kapsar, Anwar Gassim and Lama Yassen, who is just in front of me. And they had a beautiful paper about the success of of energy price reform around the world. And to study that issue, one question which is important is to distinguish between the short-run effects and the long-run effects of energy price reform. We know that an energy price reform is going to be welfare enhancing in the long run. But in the short run, there is a lot of pain, a lot of negative effects coming from the reform. And that can make the reform economically or even politically unfeasible. So when we try to design an energy price reform, it is key to consider the difference between short and long-run reactions. Another key element is the uncertainty, and to have what I would call non-arbitrary mechanisms to form expectations for the agents. Why? Because that will allow us to consider how the perception of the economic agents are going to determine what are the effects of the policy. For instance, if the government establishes a subsidy for electric vehicles, the results are not going to be the same if the agents consider that the policy is going to be temporary or if the agents consider that the policy is going to be permanent. The shift in the demand for electric vehicles is going to crucially depend on how they perceive this policy. So another aspect which is quite related to that is policy credibility. For instance, if the government also commits to a certain incentive policy, let's say, for instance, establishing feed-in tariffs to promote renewable energy, but later on, because of economic crisis or fiscal discipline or any other issues, they reduce the incentives. What is most likely going to happen in the future is that the new policies will be less effective. Why? Because the government just lose credibility on that, on setting those policies. So they are going to think that there is a non-zero probability that in the future the government is going to reduce those subsidies, so that there is a tool that allows us to really believe completely the government. And this is, by the way, what explains why central banks always carefully communicate any changes in monetary policy, because credibility is paramount for the success of the policy. So just summarizing, not taking into account these conditions, dynamics and uncertainty can lead to unintended consequences of policies.
Well, thank you very much. With that, why don't we open up to the floor, the questions. We may be able to take 3 questions. Here we go.
Thank you very much for this very interesting panel. In the list you had, these models. I also recognize some of them are familiar, but the online policy simulator is not available, which is understandable. There would be licensing term issues in some of these models. Now, in that sense, I think this is a very good thing that CAPSAC is doing, developing their own models and making policy simulators available. But then, because these are not well-established, well-known models, the user needs to trust the models. And in order to trust the models, so I need to ask, one, is the model code, are the mathematical equations, the model formulation available? And second, what about the validity of the models? How did you validate those?
Yeah, I'll take this question. Very good question. So number one we do have, for most of the models, unless it is just a visualization, like for example, PV calculator could be one visualization. Each one of them has a methodology paper. It's already available. It's usually a 20-page document. with equations, assumptions, everything narrated there. And that's one of the requirements to become a policy simulator. As far as validity is concerned, again, this is where the use comes into picture. As long as many of these papers already gone through peer reviews, journal, publish, etc., so definitely it has gone through a level of validation. But we are still seeking the feedback. Hopefully the academia will pick it up and they'll start playing with it. However, now what we are doing is these models not only being research published, we are now actively engaging with the ministry and using these models to solve their specific use cases with their specific data and producing the results and also giving a specific tool for them. So this is the way how we are approaching the validation. Yes, it's a long journey. Our journey began 5 years ago, roughly, and I think we are only 20% there. So it's going to be a little longer journey to get there. Any other questions on the floor? Somebody get the mic, please.
So I very much appreciate also your efforts, and we also at Vienna University of Technology, so in our groups we are entirely working open source in that respect. So my question is, do you have an idea how to, let's say, because at present every PhD more or less develops his own model, puts it at GitHub or Zenodo and so on, that somehow the different, let's say, communities, how to cluster the communities, that they somehow in an extremely efficient way get, let's say, involved into these modeling networks, so that in the next 5 to 10 years, not hundreds of open source models for a similar topic will be somehow developed and available in GitHub, and that things are, let's say, narrowed down somehow and accepted then on a certain, let's say, platform or format.
I guess let me rephrase the question, like, will there be hundreds of models coming in, and how do we network these with the right experts so that the models can evolve over a period of time, I guess is the question. Anybody else in the panel would like to answer that? Go ahead, Dr. Baltazar.
I have the experience for macroeconomic, dynamic, stochastic, general equilibrium models in which there has been developed open source software, and around that software it has been developed a community of modelers with forums and a conference and etc. So the basics of the methodology is shared among all of the economy. So that's my experience on that.
Yeah, one another example I could quote, there is a group, I'm pretty sure Dr. Andreas is involved in. It's called International Transport Energy Modelers Group. Again, all these models are not open source, some of them are, but 13 models have come together, modelers of their own models, and how we are engaged with them or trying to engage with them is, well, can we supply a common open data set that everybody could possibly use it. They may choose not to use it, but at least they could use one possible data set so that they can explain and compare the results of these models. Because at the end of the day, each of them is a transportation model, and the forecast shouldn't be varied like this and should be close converging at some point. And if possibly they use the same data set and we version this data set, and if the modelers call out a particular version that we have used, possibly that would explain and a better way to see the model outputs are not too much variant. So those could be two examples. With that, any other questions on the floor? Here we go, please.
Oh, shukran. Thank you so much. I have a question to Dr. Michel on minerals and I mean the problem that you explicitly mentioned in gathering and measuring data in the mineral sector and mining. So here in the kingdom, we have ambitious goals when it comes to mining, and we have a national mining company. And we also, after achieving carbon circular economy goals, and that's been explicitly mentioned often in this conference. Do you think that if we, to achieve circularity, digitalization in the mineral field would be really vital and would be an incentive to create a demand for, participants in the mining industry to come up with, I would say, metrics, data, and maybe technologies. I don't know if we have the technology necessarily to gather the necessary data we need in the mining sector. Maybe it's somewhere used in other sectors, but in the mining, do you think that would be an incentive so we can achieve circularity? We will come up with metrics, and so we can measure, I would say, starting, for example, the life cycle assessment of a given, for example, cell phones. And we start from there, and we can identify the right metrics and measurements so we can monitor minerals and the 118 elements they mentioned, so we can come up with the right data.
Okay, I think I got the gist of your question. This is a multi-layered problem, so mainly what I was describing is the difficulty of building data that reflects industry-wide activity, national activity, so that we can understand supply-demand balances and begin to kind of figure out really what we're doing. At the asset level, companies, the major companies anyway, the largest mining enterprises, are starting to collect data that will inform them about their own operations, but that is not public information. That is closely held proprietary data, as you might expect, and they are using that to try to accomplish a number of things. They need to report to their investors and their governments. They're all, if they're publicly traded, they are issuing reports on performance. So what we often think of as either corporate sustainability or ESG reporting or whatever, they have to have the data to support that. We've had, of the largest mining companies, we've had some of them tell us they know everything about their business. They know their supply chains, where materials are going, how waste is getting handled, whether they are recycling internally and managing waste streams internally the right way. So to the point that I think, or the question I think you're raising about circularity at the asset level, for the largest enterprises that have the resources and the capability to do this, yes, they're there. And this concept of digitization in mining, of course, the same thing is happening in the oil business, at the oil field level, at the asset level again. Digitization in mining, the concept of the digital mine, this is well underway. But this is, the mining industry, just like every other industry. You've got the largest publicly traded companies that have the wherewithal and are feeling the pressure to do this and actually can benefit from it, and then you have everybody else. And it's going to be a long time before the smaller enterprises are able to do that. Eventually, enough of that information does start to come together so that you build data, at the national level or at the aggregate level that becomes trustworthy. So to use the U.S. experience again, we could conceivably, if we had a mining industry that was large enough to worry about this, we could conceivably do the same thing for mining operations that we do for oil and gas. The EIA can not compel, but certainly request, and they will comply, data from refineries on operations. So we know what refinery utilizations are, we know what throughput is, we know all of this stuff. We know a lot about how refineries operate, what kind of energy they use, where it's sourced. Eventually, perhaps, We could do the same thing with mining operations. The problem is that the mining industry in the United States is, for all intents and purposes, just not, it's certainly not what it was when I was messing around in the business. And so, you know, our example is not going to work in other locations. Other countries would have to choose to do this in order to be able to trust what's being reported in production, reserves, waste, water use, and other things by other countries. And I don't know how to make that happen. So the answer is at the asset level, yes, the industry is moving in this direction. You know, the largest operators are motivated to be as efficient and to optimize as much as they can. That's certainly happening, but it doesn't really help us with the bigger problem, which is what are we doing that's creating the call on minerals in the first place? What do we actually really require? Where is it going to come from? How do we balance demand from other uses and so on? So it's a very complex, big thing.
Great, thank you very much, Michelle. With that, we are 1 minute past our end time. Thank you very much for coming in and listening into this session. Thanks to IAEE and CAPSARC for organizing this event. Sincere thanks for the speakers for bearing with all my messages and attachments, and thank you very much. This has been a great session. It was a pleasure talking to you all. One key takeaway for all of you, just Google CAPSARC data and tools. It'll land you to the page, you will see it. And this is, again, a journey that just began. We will continue to improve the availability of the data and simulators. With that, thank you very much. You all have a nice evening.